During our tutorials, we will use the interactive environment called Colab Notebook from Google, which allow us to write and execute our Python code without any setup or configuration. Just use your Google account, access to the website colab.research.google.com, and you can create your first notebook. In this video, we will discover NumPy, which is one of the most important packages for scientific computing in Python. It provides a high-performance multidimensional array object and tools for working with these arrays. Let's first create a list of COVID cases during 1 week. As we have seen before, Python library provides a list which can contain elements of different types. But pay attention that NumPy array can only contain elements of the same type. Now the question that you are probably asking yourself is why we should use NumPy array and what is the adding value of NumPy? The short answer is the performance. NumPy data structure perform better in size, performance and functionality. NumPy data structure take up less space, it's faster than lists, and it has optimized functions such as linear algebra operations built in. Let's now import the NumPy package as np so that you can refer to NumPy with np. Then we can use np.array to create a NumPy array from our previous list COVID cases, and we can print out our first NumPy array. We can also check the type of our array by using a type function. One of the key features of NumPy array object is performing mathematical operations on whole blocks of data using similar syntax to the equivalent operation between scalar elements. In this example, we can print out the COVID cases per population by doing a simple division operation. Otherwise, if we want to do the same operation using our list COVID cases, we have to apply the for loop in order to access item by item. Then we need to append the result of the division operation to an empty list. Sometimes Python list and NumPy array works exactly the same. It's the case for the slicing of one-dimensional array using the square bracket notation. In this example, we subset the number of cases during the first 4 days. In other words, we select the values from index 0 to index 4, but pay attention that the value of the index 4 is not included. We can also define a step of slicing. For instance, we subset the number of cases during the first 4 days, but with the step equal to 2. With NumPy, we can also use the comparison operators to compare the array items and returns booleans, true or false. In this example, we want to know on which day the COVID cases exceed 250. As we can see, starting from the 3rd day, we get the true value, which means that we exceeded 250 cases during these days. If you would like to get the COVID values instead of returning boolean true or false, then you only need to put between brackets your condition or conditions. Let's now try to create a two-dimensional NumPy array from a list of lists. In this example, the name of the variable COVID is a list of lists. The main list contains 7 elements which represent the weekdays. Each day is a list containing 2 elements which are the COVID cases and the number of deaths. For instance, on the first day, it has been reported 200 cases and 2 deaths. Then, we can use simply np.array to create a NumPy array from our previous list, COVID. We can use attributes like ndim to get the number of dimensions and the attribute shape to get the shape of our array. In our example, the array has 2 dimensions or 2 columns and 7 rows or 7 observations. If you want to do the slicing of two-dimensional array, pay attention that is not the same as the slicing of the list. However, it's very simple. The indexes before the comma refer to the rows, and those after the comma refer to the columns. In this example, we subset the number of cases and deaths during the first 4 days. So before the comma, we subset from index 0 to 4, and after the comma, we only put columns, which tells Python to include all the dimensions. Let's do another example. By using the negative indexing, we can get the values of the 2 last days, and we can specify after the comma the index 0 in order to return only the COVID cases. Let's now discover one of the powerful tools of NumPy, which is the broadcasting. With this tool, NumPy is able to treat arrays of different shapes during arithmetic operations. For example, we can add our array np-COVID, which has the shape of 7 rows and 2 columns, to one-dimensional array including only 2 values. So NumPy will broadcast the one-dimensional array to become compatible with np-COVID. As you can see, the value 100 has been added to each observation of COVID cases, and the value 10 has been added to each observation of COVID deaths. With NumPy, you can print out the different summary statistics, like the mean or the average. In our example, the average of COVID cases is about 578 cases, and the average of the COVID deaths is 5. If you want to calculate the standard deviation, which describes how spread out the values are, then you can use the method std. A high standard deviation like the one of COVID cases means that the most of the numbers are not close to the mean value. Let's now take a look if there is a high correlation between numbers of COVID cases and deaths. NumPy implements a CORE_COF function that returns a matrix of correlation. In our example, we need to calculate the correlation between all the elements of the first column, which represent the COVID cases, and all the elements of the second column, which represent the COVID deaths. As expected, the correlation is 0.99, which is a strong positive correlation. In the next video, we will discover another powerful library for data analysis, which is Panda. Panda is built on the NumPy package, and it allows you to store and manipulate tabular data in rows of observations and columns of variables. Thanks for watching and see you soon.